Howdy folks, welcome back. So in this video I'm just going to quickly go through the practice quiz and again show you how I go about solving problems. Again, I recognize this by no means the only way, and in some cases it might not be the way that works best for you, but if you're curious as to where to start, this kind of gives you some insight as to how I go about solving problems there. Alright. So again, this quiz is dealing mainly with exponential and logarithmic functions and equations. Alright. So the first one is combining logarithmic expressions. So it asks you to combine the logarithmic expressions into a single logarithm with a coefficient of 1. All right, so we have a single logarithm. So we want log base 2 of something, and we want the leading coefficient to be 1. So in effect, we don't want to have this 3 outside the logarithm. All right, so everything is going inside the logarithm there. All right. So you kind of follow the same order that you do with order of operations. So here we're multiplying first. So to simplify, if we're multiplying something outside our logarithm, what we can do is we can take whatever we're multiplying outside and we can just write it as an exponent inside our logarithm. All right, so you have the log base 2 of a minus log base 2 of b to the third plus log base 2 of c. Right, so again, we can take whatever is outside our logarithm, we can bring it in, and when we do that, we write that as an exponent there. All right, so the next step here is we're subtracting 2 logarithms. So when you're subtracting 2 logarithms, you can rewrite that as a single logarithm, and then you're going to take the logarithm of the quotient. All right, so the first number is going to be up top, and the number that is just the value you're subtracting is going to be the numerator of your fraction there. All right, and then finally, if we're adding 2 logarithms with the same base, we can combine those into a single logarithm, and we take the product of my 2 arguments. So you have a over b to the third times c, so that would just be ac divided by b to the third. All right, and that is all that question is asking. All right, so the next question here is solving an exponential equation. All right, so your first step is to determine if you can rewrite both sides in terms of the same base. Again, if you can rewrite both sides in terms of the same base, you can just set the exponents equal to one another, and then you can just solve that corresponding equation here. In this case, I can't rewrite 20 as 5 raised to some power. So although it's 5 times 4, again, we need to have it 5 raised to some power in order to apply that technique there. All right. So if you can't rewrite both sides in terms of the same base, what you can do is you can just take the logarithm of both sides. So you can get the logarithm of any base. Again, I like using the natural logarithm just because your calculator has a built-in function for it. That and ln is relatively uniform as far as the natural logarithm definition goes. If you use the logarithm, so if you just use log, oftentimes that's a common logarithm. So that would be the log base 10. However, I've seen some places where that ends up being the log base 2. So again, that can get a little bit confusing. But again, as long as you're using the same logarithm but the same base on both sides, you're allowed to use any logarithm you like there. All right. So again, when we have a logarithmic expression of an exponential expression, we can kind of do the reverse of what we did with the 3 up here. So we can bring that exponent out front, and we end up multiplying. So you have x times the natural log of 5 equals the natural log of 20. So then to get x by itself, we can just divide both sides by the natural log of 5. Divide by natural log of 5. So you end up with x is about, and yeah, on the quiz I should probably tell you how many places I want you to round to. Yeah, I'm gonna go ahead and go 3. All right, so when we take the natural log of 20 divided by the natural log of 5, we end up with 1.861 or thereabouts. So that is going to be my answer. Which again, you can do a quick check. So 5 to the first is going to be 5. 5 squared is 25. So 20 is somewhere between 5 and 25. So that means that your answer should be somewhere in between 1 and 2, which just fits the bill. So that is going to be my answer here in this case. All right, and the final problem here is dealing with solving a logarithmic equation. So to solve an equation involving logarithms, your first step is you want to get it so you have a single logarithmic expression all by itself on one side. All right, so here we are adding two logarithms, so we can combine those into a single logarithm. And we're going to take the logarithm of the product in this case. So we have x plus 5, x minus 3 equals 2. All right, so once you have it, so you have a single logarithm on one side, you're just going to convert this to an exponential equation. All right, so to do that, you're going to take whatever your base is, you're going to raise it to whatever power your logarithm equals, and then you're going to take that and set it equal to whatever you're taking the logarithm of. All right, so I'm just going to go ahead and expand this out. So we have x times x is going to be x squared minus 3x plus 5x, and then minus 15. And that is equal to 3 to the second. All right, so combining like terms here, we have x squared minus or plus 2x. And then 3 squared, that's going to be 9. So we're going to, I think we want to subtract a 9 there. We're going to go ahead and subtract a 9 from each side to get everything on one side, so it's in standard form. So negative 15 minus 9 is going to be minus 24. And that equals 0. All right. So at this point, it's just a matter of solving this quadratic equation. So again, you can use between the square, you can use the quadratic formula. In this case, it does end up factoring nicely, so I'm going to go ahead and factor it. But again, either route you take, you'll end up at the same destination at the end here. All right, so you have x and x. All right, so we're looking for two things that multiply together to get negative 24 and add together to get positive 2. So that would be plus 6 minus 4. All right. And again, since we have a product equaling 0, to solve this, we can just set each factor equal to 0 and solve the corresponding linear equations on there. So we have x equals negative 6 and x equals positive 4. All right. Now it's important that once you get to this point, you go back and make sure that you don't run into any trouble when you plug these values back in. All right, so again, as far as domain restrictions go, we have 3 rules. We can't divide by 0, can't take the even root of a negative number, and we also can't take the logarithm of a negative number, or any number. I don't even think you can take the logarithm of 0. Yep. So yeah, so any non-positive number, you can't take the logarithm of. All right, so when I plug in negative 6 in for x, I end up with 2 negative numbers inside my logarithms. So I just ignore that option. All right, when I plug in 4 in for x, I'm going to the log base 3 of 9 plus the log base 3 of 1, which the log of any base of 1 is 0. And 3 squared equals 9, so the log base 3 of 9 would equal 2. So yeah, so that would be my final answer there. All right, so again, that just represents how I go about solving problems. Again, I recognize it's by no means the only way, and in some cases, that might not be the way that works best for you. But if you're curious where to start, hopefully that gives you a little bit of insight as to how I would go about solving the problems. All right, thank you very much. Have a wonderful day, and I'll talk to you all later. Bye now.